What's up, YouTubers? Today from the lab. Here working on amplifiers tonight, so late. It's like 11 o'clock. Working on my stupid amplifier today, and I'm listening to HP Powerwall. And I'm tuning this amplifier, and I'm thinking to myself, I'm setting these things for milliamp load on the old tube amps. How we used to set them up. You have to match the tubes up to load. We have a potentiometer in here. It allows us to adjust the load to setting the tubes up to get the right balance for the sine wave, so you have a clean sound. And I was thinking to myself, I'm listening to HP Powerwall, and I said, wow, I wonder if I could test 18650s that way. If we could figure out what makes a good one good and a bad one bad. Now, we've been testing these things for milliamp draws. As far as I can see, all of us have. I have, this one has. And we never really look into anything other than milliamp draw. And I decided today, I'm supposed to be working on my amplifier today, and the next thing I know, I'm sitting here with 18650s all day today. But what I found out is sitting here running these things, is that what makes a good battery good, a new battery good, or even an old battery good and shitty, or, you know, well, if you load test a battery, and the easiest way to do it is any of us who are doing these things or testing these things, 18650s, are going to use either an AccuCell or a Turnigy, whatever. We're going to test them. It's going to show. We're going to set the charger at our desired rate, probably 1 amp, and we're going to let these things rip until they're going, you know, from 3.20 to 4.20 in voltage. No problem. We're going to read the milliamps, and we're going to put these into our packs. Just like me, I run a monster 150 cell pack. We're going to put all these things in there, and we're going to do it because it says 1800 milliamps or 2000 milliamps, and that's going to be the set number we run these things at. And that's the end of that. Well, what I kind of found out today really isn't the end of that. And the reason being, what makes a cell age and what it does to it. Well, aging in a cell, best way I could put this, is like an air filter in your car, okay? You run in the air filter in your car, you drive it from here to there, you never really rev the car, so the air filter is always good. You're only drawing a little bit of air through it, even though it's getting dirtier. Same thing goes for our battery. Because it's a chemical reaction, as they get older, it's my understanding, and not really my understanding, but kind of what I'm seeing testing them, is that the reaction happens less. So its ability to give stored energy at that rate becomes less. Not that the milliamp hours become less, which is kind of good to anybody building a Powerwall or this and that, because the old laptop battery still can take 2200, it could take 2000, and I'm using these numbers as a general. It could still take 2000 milliamps. The problem is going to be, and what I found here today is with testing new ones and old ones, and I even have new ones sitting on there running right now because I wanted to see and have some real numbers to this. If I was to take a new battery and I ran it at 1 amp, okay, the second I put that amp on there, under draw, that battery went right down to 4 volts, okay? That was under a 1 amp draw, and that was the second I put it on there. So I started at a 4 amp draw. I did this 15-minute intervals so we could end up with a 60-minute amp or 1 amp hour rate, whatever, 4 amp hours in this case. But after 15 minutes of running that battery at 1 amp, and this was a new one, this was a 2000 milliamp. It was not a great cell, but it's, you know, I'm not trying to grab Sanyos off the shelf here at $12 a piece. We're going to use stuff this is why we're watching this channel. So 15 minutes into it, the battery was down to 3.87. 30 minutes into it, still drawing 1 amp, it was down to 3.77. 45 minutes into the test, it was at 3.70, still drawing an amp. After an hour, it was down to 3.64. Okay. Now, we know that it was drawn in amps, so every 15 minutes it was 250 milliamps worth of current going into the battery. So none of that had changed. We had it was at 60 minutes, we put in 1 amp hour into this battery. Okay, because we had 250 milliamps per 15 minutes. Or no. Yes, okay. 250 milliamps per 15 minutes. For 15 minutes? For 15 minutes. So, we ended up at 1 amp hour going into this. Or 1 amp hour, and this was draw. I'm sorry. This is the current. I was using current from this battery. So, a brand new one. I started at 4. On the first second I turned it on, it dropped down to 4. And then, like I said, 3.87 at 15, 3.77 at 30, 3.70 at 45 minutes, and 3.64 at 60. Now, what did this say? Well, and it used 1 amp hour. This was 1 amp hour worth of electric in here. So, that was a new battery. Then I took the same milliamp hour, I guess it's either Sony or a Sanyo, old laptop battery on an HP laptop. I actually broke my battery today just so I could do this stupid test, but because I have no broken laptop batteries. So I turned around and fully charged 4.2. I started that cell. And then the first time I turned it on, it went down to 3.82. Same milliamp rating as the one I was working with, the new one, but yet it went to 3.82. Within 15 minutes, at that 1 amp draw, this battery was down to 3.48. Still drawn 1 amp, 250 milliamps for its 15 minutes, 15-minute cycle so far. At 30 minutes, it would have been at 500 milliamps. Like I said, the milliamps are never changing because we're using a constant of 1 amp in the charging here. We were down to 3.39. Now, I got screwed up in here, my thing, but at 76 minutes, this battery was down to 3.20. Okay, and at 0.7 amps. So the charger started cutting current to this. All right, now this is where this all becomes relevant now, is because we have 2200 milliamp hours or 2000 milliamp hours in this battery, but we only have so many milliamp hours of usable power at 1 amp. Does that make the battery beat? No, it doesn't make the battery beat, because in like an HP power, in a Powerwall, or any type of situation, monster battery pack like this, where you're going to use a whole lot of batteries, and even a whole lot of old laptop batteries, your amp draw is going to, you could bring your amp, if you're using 100 batteries in your bank, you're not going to see this if you have, so if you got 100 batteries and you're drawing 100 amps out of there, you're going to see 1 amp per battery. Okay, these numbers are going to become real relevant real quick. So where the problem comes in now is, it's not that the batteries lose a lot of their ability to store energy. It's that the batteries lose their ability to give the stored energy in the higher amperage range. And we're talking only an amp here. I mean, we're getting rid of the whole bank of cells, and I'm saying this because this one battery, I put these all together as a bank. This is a brand new one at 2000. This one is a used one at 2000. This one is a used one at 2000. Now, I start drawing off this battery bank. Okay, they all have the same milliamp rating. The only difference is now this battery is going to have to supply a lot more current. These are going to want to drop off under that 1 amp draw. they're still drawing the same thing, and their milliamps are, what's happening is, because they're older, the battery loses its ability to use the stored energy at the high amperage. So then what happens? Inside of our bank of a whole bunch of cells now, this battery can only, so this thing, as soon as it went under load, it started to drop down, but all these other batteries made up for it. They're taking up that load now. They're the ones that are, they're the dominant batteries in the pack. It doesn't mean there's anything wrong with this battery by any standard. It's just that it's not able to supply the load for the length of time that you're trying to use it for. Does it make it bad? Again, no, it doesn't make it bad. It just means that we have to plan around the whole battery game in a kind of a different way. Instead of looking at milliamp hours, you might have an 1800 battery sitting there and saying to yourself that this battery sucks because it's at 1800 when I tested it. But in the reality, at 1800, that battery may end up being good because it'll deliver that 1 amp for an hour, whereas the other one will fall off. So writing one of these off because it has a lower milliamp hour may not be the whole thing. Now, the same goes for charging, which is weird too. I was writing that down, and that's one of the tests I got going on here. If you are charging one of these things, okay, and if you take your AccuCell charger, and all this stuff is going to be done, like I'm just saying, through a standard charger. You're going to turn that charger on, and you're going to put it on an amp, and you're going to see instantly what happens to that battery. The first number that you write down is going to be where that battery went to the second it's seen that amp. Well, when I had a new battery, I popped that thing on the charger at 1 amp. Now, I didn't get to see it right off the start, but this is what I can tell you. After 15 minutes, that battery was already at 13.83. That was a new battery, okay? After 32 minutes, it was up to 3.90 volts, 63 minutes up to 3.95, 91 minutes up to 4.06, after 100 minutes, 4.10, 106 minutes, 4.14, and it was all the way back up to 17.74 milliamps. Now, what happens in the charging game is this. We're just seeing our chargers are, we're plugging these things into our chargers. Our chargers are sensing these things, are taking them up to their high voltage, or their highest voltage. Say they're going right up to 4.19. What's happening is then the charger is cutting down the amperage. The battery is then accepting the charge. And they'll sit there at 4.16 to 4.20, just accepting that little 0.2 amp charge for hours, and that's where we're getting all our milliamps. That's where we're seeing all these high milliamps coming from these batteries. Are they accepting the charge? Absolutely. But are they accepting the charge at the amperage you're trying to put back into them? No, they're not. And the evidence of that is easily just put one of these things in your charger, take a new one, take it out of the charger. But the crazy thing on all this is that the lithium batteries really don't lose a ton of amp hours. What they lose is their ability to be able to supply or even accept current at the high rates. If you get to where I'm going with all this, kind of gives us a different way of testing. So what I want you to do is real easy. You're gonna take these, like I said, you're gonna take the battery, you're gonna shove it in your charger, and instead of just looking at the milliamp draw, see how long that charger delivers that 1 amp to that battery, and write that down. Okay, as it's going, every 15 minutes, write down the number, see where the number is. As these things take charge like that, or even as you're gonna do it for discharging, doesn't matter. As I've done the paperwork, whether it's charging or discharging, it's going to show you the same numbers. It's just going to be a graph in a different direction, which is nuts to me. That it really showed itself today when I put them through a different kind of test as to what made a good battery good. The great thing about this is that with the used laptop batteries, you're going to find, and this is probably why we see, you know, we all pull apart laptop batteries. I've pulled hundreds of them apart myself. And what you see is you'll see the voltages are there. These batteries will come in and, you know, you see a lot of them with 3.5, 3.8, 3.2. You know, they're there. They're good batteries. What's making them dead in a laptop pack, besides having a bad cell or any of that, and we're throwing that right out the hole, is the ability for the battery to deliver stored energy in a timely rate. Okay? And I say it again, if you have a bank like this and you take the batteries and you start to do it, and this battery, even though it has the same milliamp hour, cannot supply the amperage for the same amount of time as this battery can. This battery is going to be the one that picks up for that, and everything else in line. So, you know, it's, even though this battery is going to be there, it's just going to be, it's only going to be putting out its 3/4 of an amp or an amp that it wants to put out, because that's all it can do. It's all it can supply. Now, what happens when you're charging? This is something I have to look at, and that being, if you're charging a whole bank of 100 of these, okay, with different intake. So I bang the voltage in there, and I'm cranking these things up, and, you know, we're at 3.80, and this thing's taking 5 amps, you know, or an amp of battery, we'll say, times 100 batteries if I was dumping 100 amps in there. And the reality is, this is what I'm seeing, because we're seeing a whole bank of batteries tied together. Voltage is not going to change in these things. We're not going to see the difference. The difference is going to come from, will this battery now, is my curiosity, say to itself, I'm not going to accept the same amount of voltage as this because there's a difference in resistance. Will voltage travel to the path of least resistance? Will current travel to the path of least resistance? And that's what I'm getting at, is we're charging the whole bank up, and we're seeing the 4.20, and the bank is shutting off. But in reality, there's 10 of these cells sitting in this bank that could have been charged at 4.19 at 0.2 of an amp for another 10 hours. Okay, that would have brought that that's where the storage capacity lies in these things. Okay, is in that, maybe that last bit. It's not so much it can deliver the amperage, but like I said, the good thing, again, we got 2200 sitting in this thing. It's just that we need to utilize that area. That would be a bad area under high amperage draw, but it's a usable area in a bunch of batteries. Now, I'm wondering, same way I put this video out, would it be better to not only utilize the milliamp rating for balancing a set of batteries, but also utilize the amp draw per hour to where it finally starts falling off? Because if you get 10 cells and after 1 hour, all those 10 cells showed, you know, that they all had 3.6 left in them, and you put those banks in there, even though the milliamps may be off from the cells, what it can draw for the allotted period of time will keep the bank balanced, which should also come in for charging, is what I'm saying. And that's what I'm getting at with this video, is that we're trying to charge these huge banks of cells, and we're thinking they're charged, and they may not be charged, and they may not even fully be discharged. And one of the things I seen with HP Powerwall was, he took a battery out, and the battery jumped back up to 3.6 volts. And that's a perfect example of what I did before in one of my tests, and it did exactly that. Even though I was pulling an amp from it, and the thing fell on its face, and at that point, your inverter would have shut off. The reality is, when you doubled that bank, and this thing went down to only drawing half an amp, well, that battery's not going to shut off anymore. And you're going to get to use all that last of that power that's sitting in there that you couldn't do it in amp, but you can do it 1/2 or 1/4 of an amp. And the same may be true for charging. So just throwing that one out there to you guys. You know, like I said, take the battery, throw it in a charger, 15-minute intervals, look at the battery as it's charging. Is the voltage jumping up real high? If the voltage jumps up real high on that battery, it instantly goes to 4.2. You already know, or 4.10, that this battery is going to suck for pulling in a charge, and it's probably a worse battery to put in a pack. If you put if you put that same 1 amp into it and you're charging it up from 3.20, and you notice, wow, the thing only goes to 3.5, and then it slowly comes up. Well, that battery is accepting the charge. Hope I'm getting this across, because it may sound stupid, because, I mean, in theory, we measured 1 milliamp hours, but it absolutely is not. It's a little of both. Amp draw and this. And I think when we're balancing a big bank like this, because what ends up happening is we go to charge these things, and we find out that we got different banks, and we're thinking they're unbalanced. Well, they may not be unbalanced. It just may be that other banks are accepting the charge better than this bank is, because the battery can't accept that charge, and it accepts it slower. Doesn't mean it's not taking the milliamp hours, it just wants to see the milliamp hours slower. And it's a bunch of things. I had a bunch of things on my mind today. Second being BMSs. Our BMSs in the solar application, are they good for because we're balancing a battery pack? But what's happening when we're balancing a battery pack? Are we wasting solar by using a BMS because a BMS is bleeding off current? Question 2 today on my list. Okay, and that's about it for today. I appreciate you watching, and trying to add my 2 cents into this whole Powerwall 18650 menage, as I'm quite invested. There's a bunch of other people, as you can see. So, and I think on the next thing here, because we're in the lab today, I never get to say hello from the lab to you guys. So, my workshop, the lab, fucking man cave, whatever you want to call it. But supposed to be working on my amplifier today, and you ruined me today because I'm working on stupid batteries. But I can't sit here for the life of me and start linking hundreds of batteries together and have failures, because it kills me to redo this shit 20 times in a row. And there's got to be some sane way that we could sit here, and at the same time that we're testing these things for milliamps, we could be utilizing this time for also testing them for amps, amp draws, and in charging and discharging rates. And by the time you do that, you'll have no question as to if you have a good cell or not. And that bar, like everybody said, you got to let the cell sit for a couple weeks after it's charged, and blah blah blah, to make sure you have no. We're not even speaking to that. That's in a million different articles on the 18650. The only thing we're talking about today is something I never hear out there, which is what makes these things go bad. And like I said, if this cell's like 5 years old, and this thing can still take 2200, milliamps. Maybe not this one, but it's nice Sanya though, whatever this is. We'll take 2200. Okay, that's a lot to say for the lithium. So what it is the lithiums really aren't losing a lot of capacity over the time. What they're losing, I'll say it again, is their ability to deliver the stored energy at the rate to which we want it. If we comply with what this thing wants to give, doesn't matter whether it's new or used, it's going to supply. And great idea to use laptop batteries for Powerwall, because you're going to put tons of them in line anyway. Just we need to find a better way to test them, so we're not shoving them in there and having to take them back apart, because I've been there. So I appreciate you watching, and again, next video on modifying this Sunco battery welder. Okay, what's the problem with the Sunco battery welder? All right, here we go. Okay, I want to weld this battery with my Sunco. Why can't I? Because going past one cell, I have to build my battery banks one at a time. Dug, 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 dug. Put another thing on there. Dug, 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 dug. I can't assemble a whole battery bank. So what I'm going to do is I'm going to take this shit apart on here. I'm going to put a set of wires off the end of it with a set of big thing and a set of leads, so I can utilize this 4 or 5 cell configuration like this. 4 or 5, we'll call it 4 or 5 cell configuration versus the singles. How did I spend all day working on batteries when I actually wanted to get something done today? Oh well. Subscribe. Give me some feedback. It just keeps me motivated. Have a good night, guys.